Welcome back. In this video, we're going to go over section 4.3, which is even more story problems that can be solved using systems of equations. In this section, we'll focus on mixture problems. We've dealt with mixture problems before, but just to remind you how this goes, with mixture problems, we're typically looking at combining or mixing a couple of things, and there's a couple of attributes associated with each of the things that we're mixing. For example, we might be combining two different types of candy that have two different prices, and we're doing two different weights of each of those candies. So each type of candy has a price and a weight. And we're blending those two or mixing those two, and we have to satisfy a certain requirement about the weight and a certain requirement about the price. Another example would be a typical coin problem where we have a jar of coins and there's a different number of, let's say, pennies and nickels. And of course, a penny and a nickel have two different values. So the two attributes there are going to be value and number of coins. And we'd be combining those two objects and satisfying a requirement about the number of coins and about the dollar amount. So all of these mixture problems have a similar sort of feel. The first problem that we'll look at is another kind of typical mixture problem example, and that's a ticket problem. So here the story is a ticket office at the zoo sold 553 tickets in one day. They made a certain amount of money, $3,936 for selling the tickets. And then it says how many $9 adult tickets and how many $6 child tickets were sold. So we want to know how many adult tickets and how many child tickets were sold. And the two kind of attributes in this question are the numbers of tickets of the two different types, child and adult, and also the dollar amounts that are earned for selling these two different kinds of tickets. So we're going to have two different equations. One equation will be about tickets, and one equation will be about money. So first step to do is to pick out some variables. I'm going to let A stand for the number of adult tickets. And then we'll let C be the number of child tickets. If you want to use X and Y, go ahead. I find that using like meaningful letters like C for child and A for adult is easier for me to get the right answer. Okay, so our first equation is about number of tickets. So we know that A, adult tickets were sold and C, child tickets were sold, and that has to make a total of 553 tickets. So that was the easier equation. The next equation is about the money that's earned. So adult tickets cost $9 each. If we want to think about how much money was made by selling those tickets, then it's going to be $9 for each ticket times the number of tickets. This would be the money for the adult ticket. Okay, for example, if they sold 10 tickets, it would be $90, right? 9 times 10 is 90. So for the adult money, it's 9A. And then the child tickets are $6, so that'll be 6C. And then that will make 3,936. Okay, so our first equation is about tickets. Our second equation is about money. And that's our system of equations that we're going to solve. Before we do, make sure that you're clear on where that system of equations is coming from. And we're going to go ahead and solve that right now. And so let's take a look at the system. A plus C is 553, and then the second equation, 9A, 6C, that's equal to 3936. I can see in that second equation, it'll be helpful if we could divide out that common factor of 3. I think there's a common factor of maybe 9 also. Let me see. No, 9 doesn't exactly work, but we can get the 3 out. So let's divide through by 3 at least. We'll keep the first equation the same, but we're going to divide the second equation by 3. So the first one, let me recopy it. A plus C is 553. Then we'll have 3A plus 2C, and then that will be 13. Sorry about that. Okay. All right, so I divided 3,936 by 3, getting 1312. So now we want to solve this system with the simpler numbers. So we could eliminate A's. If so, I multiply the first equation by -3. We could eliminate C's by multiplying the first equation by -2. I think I'll do that instead. So we're going to multiply the first equation by -2. Okay, so that'll give us minus 2a minus 2c, and then that's negative 1,106. And then the second equation will stay the same. Okay, now the all right. Now, when we add together the two equations, we'll see that the c's go away, and we'll just be left with a. So that's 1312, and we're going to subtract 1106. So 206 adult tickets looks like. Okay, and then to get the number of child tickets, I think it'll be easiest just to subtract from 553. So we know that 206 plus C has to be 553. So then C will be 553 minus 206. And that's 347. Okay, so it looks like 206 adult and 347 child. All right, that takes us to the end of that problem. Okay, pretty typical ticket problem. Another category of problem that you may see would be stamps, like postage stamps. Back in the day, there used to be more such problems when more people used mail for things. Nowadays, there's not so much people mailing things, definitely not with different prices of stamps. So you don't see many stamp problems, but if you do, they're worked out in the same way. Okay, instead, let's work on a coin problem. The story here is that Caitlin has $8.55 in quarters and dimes. The number of quarters is 3 more than twice the number of dimes. We want to know how many dimes and how many quarters Caitlin has. So there's going to be two attributes to this question, a dollar amount and then the number of actual coins there are. And then the two variables are how many of each type of coin there are. That is the number of quarters. So let's go with Q as not equals today for some reason. Q will be the number of quarters. And then D will be the number of dimes. Okay. All right. So then let's go with the money equation first.